Hello everyone and namaste. Welcome to the fifth chapter of Arduino with Sudip. Today we are going to do a lot of interesting programming stuffs using Arduino codes in TinkerCAD. So let's get started. Okay, like we saw in chapter number 4 from last time, we can write Arduino codes in TinkerCAD using this text block. So we have the setup where one LED is connected via a resistor to the Arduino digital pin 13, and the other pin is connected to ground. So we have written a code that lets us blink the LED every 1 second. That is 1,000 milliseconds. Now let's upgrade this code and let's try to include more than one LED and see what happens. Okay, we'll just click on it, Control C, Control V, and there we go. We have another LED. Control V, and we have another LED. So let's do the same with the resistor. Control C, Control V. Okay. Looks like there might be a problem over here. So let's just drag it down. Another resistor. The same configuration. Now let's just change the color. Oh, sorry. This is the wire color. Sorry about that. So the color of the LED can be changed from here. So yeah, that's yellow, and the other one, let's turn that to green. Okay, it's almost like a traffic light. Now we'll do the same connections, but we will use different pins. Looks like my computer just got hung up on me once again. Okay, so we're back, and okay, so the positive end, let's take that to D12, and from this one let's take this to D11. Okay, now the negative end has to go to G and D. Now there's a better way of doing this. Let's do it like this. Instead of taking the ground pin from every LED connections, we'll just use the power rail that's already given in the breadboard. So we'll just use this over here. That goes to negative. This also has to go to negative, and this terminal does also have to go to negative. Now the negative terminal can be just connected from here like this, so there's no more confusion. Now instead of using the green wires, and which is not the actual color code for using positive and negative, we'll just use the negative wires as green, and the rest we can use it as red. So that way we have a clear understanding of which one is going to the positive and which one is going to the negative. Okay, now let's check our code. So in this code we have LED built in, that is the output, that is number 13. Let's just change that to 13 so that there's no confusion. There's 13 and there's 13. Now instead of just blinking 13, we are going to blink 12 and 11 as well. 12 is yellow, 11 is green. So we need to first declare that. So like pin mode, let's start with 12 output, and pin mode 11 as output. Now okay, that's my keyboard. The key got stuck. So now we have digital pin 13 going on and off and on and off. With that, what we're going to do, we are going to use pin number 11 and 12 as well. So let's just copy and paste that. And let's start with pin number 11. Okay, let's start with pin number 11. We'll just high and low that, and then goes 12. Okay, high and low that, and then we have 13. Now let's try to simulate and see what happens. Okay, the debugging. There's something wrong with the code. So it seems like your code has some errors. What's the error? Okay, so just check this one out. It's a silly mistake. It's a typo. In function void setup error, pim mode was not declared. Obviously, there's nothing called pim mode. It's pin mode. Okay. Now let's start the simulation once again. Okay. So now you can see that the LEDs are blinking. First, pin number 11 LED of green is blinking, and then the yellow one and the red one. Now this this doesn't create much of a pattern, right? So if we want to say, for example, create some kind of a dancing LED, then how cool would that be? But with this code, it looks pretty clumsy. So let's stop the simulation and let's try to make the LEDs dance. So we'll just change the timing over here. Okay, let's just see what happens when we do this. Okay, let's keep it 100 and let's give this 2000. Let's not wait 2000. Let's do 400. Let's do 600 on this one and 100 on this one. Okay, now let's start the simulation once again. Now you can see the LEDs are what happened here? Okay, it's got too slow. That's 6006 seconds. We waited 6 seconds. I was supposed to give it 600 and not 1000. Okay, let's start the simulation now once again. And now you can see the LEDs are just lighting up in a very different fashion than before, and it's not looking very clumsy. Now this is not very interesting either. So let's use something. What we'll do is we'll try to randomize the LEDs. Okay, which one lights up after which. Let's randomize that so that it becomes even visually appealing. Okay, we'll try this. Stop simulation. Okay, so for using random LEDs, so random in the sense from 11 to 13. Okay, so we have 11, 12 and 13 number connected to the LED. So let's try to randomize the LEDs and let's try to blink it on a random pattern so that it doesn't repeat itself and it doesn't look very like a robot. I don't know, how do you put that on? Okay, so what we'll do is we'll use a function given in Arduino called random. Okay, it's very easy. RNDOM, random. Now what this function expects you to write is a random number between a certain range. Okay, so it's 11 to 13. That's all we got. So 11, 12 or 13. So it will randomize. Now where do we put this? So let's create something called a variable. Okay, so what's a variable? Variables are data types that can hold values, and the values keep changing over time dynamically because of the program. So now, for example, say we write a variable and we call it random number. Okay, random. So that's random number. You can write anything. You can say write apple, but an apple holding a random number doesn't sound very realistic. So we'll just write random, okay, or random. So the random is going to be this one. So it's going to be 11, 12 or 13. It can be anything. Okay. Now instead of writing all this, what we'll do is we'll just clear this off. Okay, let's just delete the comments also. It's just not so visually appealing to me. So let's just put that as RANDNUM, random. That's high, and rand num is low. Okay, so we have two random We have two random number pins, and that's going to be set either to high or either to low. Now let's operate this and see what happens. Okay. Yeah, you can see. So there's a problem. It's never switching the random pin number 13 to high or low. So what it does is it takes this range, this 13. So it stops at 13. So it's only taking inputs 11 and 12. So we'll just write 11 to 14. So 14 won't be counted. It'll be doing random on 11 to 13. Now let's check that out. Oh, see? Now the red LED is also lighting up. Now another thing, even though the LED on and off patterns have been randomized, what about the number over here? See, the number hasn't changed. I mean, the delays hasn't changed. So the delay is either just 100 milliseconds or 500 milliseconds. So instead of that, let's just randomize that as well. So this was random number for the digital pins. Now what do we have? The range we have is, say for example, we want to do something very slow. So we'll keep the maximum limit to 1000 milliseconds. That is 1 second. So let's say rand sec. What the hell? So this random seconds is random. So it'll be from let's keep the minimum to 100 and the maximum to 1001. Okay. So this has to be replaced with rand sec. This also rand seconds. Okay. Now start the simulation and let's see what happens. Okay, so now we have a blinking LED pattern that is very random, and that is that's actually working like a dancing LED, and even the timings are different. Now you can see the time, the LED blink and blinking off is kind of slow, so we'll just try to make it a little faster. Instead of using 1001, we'll keep the maximum limit to full. Sorry, let's stop the simulation first. It'll not allow us to type in. So let's keep that to 401. So 100 milliseconds to 400 milliseconds. Let's start the simulation again. And look at the dancing pattern. It's much quicker. So TinkerCAD simulations are a little slower. If you would have done this in the breadboard in a physical breadboard using physical LEDs, then you would notice that this actually the timing is going to be a little faster. The timings are going to be much faster, way faster. Okay. So we'll stop the simulation now. You just learned how to randomize the LED. Okay, now since we are at it, we have three LEDs, red, yellow, and green, and that they look identical to what a traffic signal would look like. So we'll just try to program a traffic light. Okay, so we'll just write the comment what is traffic light code. And okay, 11, 12, 13 set us output. That is good. Now instead of this, let's just delete this. And what are we going to do first? Let's start with the red light. Okay, so the red light comes up, and I think that's the light that stays up the most. So we'll just do digital right. What is red? Red is pin number 13. So it's 13 stays up. Okay, so first of all we need to set it to high, and then we need to delay it for the longest among the three. Let's keep it to 5000. Okay, just for educational purposes, we'll just write 2000 so that we don't have to stay here for a long time waiting for it to light up and light up. So digital right. The next one comes up as yellow. So before the yellow comes up, we need to switch off the red light. So let's switch it off, and without any delay, we'll switch on the yellow so that when the red switches off, the yellow comes up. So digital right 12, and let's set that to high. The yellow won't stay as long as the red one, so what we'll do is we'll just do 1000, and fine. Now after the yellow, it's green. It's a green signal, so it's digital right. First we need to switch off the yellow. Okay, first we need to switch off the yellow. After that, we need to immediately switch on the green, and I think the green will stay longer, so we'll just do green is 11, so it's 11 number pin, and 11 is high. After that, we'll do a delay, but how long? Let's do 3000 milliseconds. That's 3 seconds, and then we'll switch it off. Now just as it switches off, this comes on because it's a loop. So 13 is red. Let's see how this works, and let's see if we have created a traffic light signal or not. Start simulation. Okay, first red comes up, stays for 2 seconds, and what happened over here? Yellow. Okay, yeah, yellow has just 1000 timing. So in order to make it a little realistic, let's just increase the timing. So this will be 3000, this will be 2000, and this will be 4000. Okay, now let's start the simulation again. So the red comes up, stays for 3 seconds, and the yellow for 2 seconds, and the green stays for 4 seconds. Wow, that should do. So now that's the traffic light code for you in Arduino. I hope this helps, and we'll come with the 6th chapter. We'll dive into some kind of loops, and we'll do a lot of interesting stuff. So see you in the next chapter. Bye bye, take care.